All right, let's jump right into something pretty wild. Forget everything you think you know about software development. The idea of a single person coding away. We're stepping into a whole new world where software is built by humans in partnership with entire teams of smart AIs. It's a brand new way of working together, and believe me, it's changing the game.
So here's what we're going to cover. First, we'll talk about what it even means for AIs to have a team. Then we'll hit the biggest roadblock they face, what's called the predictability puzzle. After that, we'll look at a really cool new solution called co-programming and its instruction manual, CoPMA. And finally, we'll get to the results, which are frankly pretty amazing and hint at what's next. Okay, first up, when AIs form a team. Seriously, picture this, a development team where every member is a different AI agent. You've got one that's a total pro at research, another that can write code like a master, and a third that's a genius at analyzing data. The mind-blowing part is they don't just wait for you to ask questions. They actually work together to build really complex stuff from scratch.
And that brings us to this key idea, multi-agent LLM applications. Let's just unpack that for a second. Multi-agent just means you've got several AIs working together. LLM tells you they're all powered by large language models, the tech behind things like ChatGPT. But here's the crucial bit. They're not just sitting around chatting. They're actively using tools and digging into data to get real, complicated jobs done all on their own. The big shift here is from having one AI helper to having an entire AI workforce. But with all this incredible new power comes a huge problem, and that brings us to our second section, the predictability puzzle. Turns out building things with creative, intelligent AIs isn't quite as straightforward as writing regular old code. So this is the big question, right? This is what every developer in this space is wrestling with. LLMs are so powerful because they're creative, they're flexible, but that also means you never know exactly what you're going to get. Ask the same thing twice, you might get two different answers. But software has to be reliable. It needs to do the exact same thing perfectly every single time. So how do you get those two things to work together? And this slide, wow, it really nails the core problem. On one side, you have the LLM world. It's messy, it's creative, and it's fantastic for getting ideas out fast. And on the other side, you've got the good old code world. Predictable, stable, and super efficient. The real challenge is figuring out how to tap into all that creative power from the LLM world without giving up the rock-solid stability we need from the code world. Okay, so how do we fix this? Well, that brings us to our third section and a really powerful new way of thinking, co-programming. The idea is so simple, but it's totally profound. Stop thinking of the LLM as just a tool that you give commands to. Start thinking of it as a partner that you actually program with. And the way this philosophy actually works is through a method called CoPMA. Think of it as a structured game plan that lets a human developer and a team of LLM agents build something together, piece by piece. It gives everyone, both human and AI, a shared playbook so they're always on the same page, constantly building and making things better. And this quote just perfectly captures the whole idea. CoPMA is all about helping you decide which jobs are best for the creative, kind of unpredictable AI, and which jobs really need to be locked down in solid, predictable code. It's a constant balancing act, moving tasks back and forth to get the best of both worlds. So, what does this actually look like when you're building something? In Section 4, let's open up the CompI playbook and walk through a real example from the research, creating an app that can automatically find and review medical research papers. Okay, so the secret sauce to CoPMA is this thing called the feature block model. Honestly, you can just think of it as the project's main to-do list. A feature is just a thing that needs to be done, and a block is who or what is going to do it. Is it a chunk of code a human writes, or is it a job for one of the AI agents? It's that simple. It's a shared plan that keeps everybody on the same page. So here's how they started. The developer just made a simple outline, a basic feature list. The main goal was snowballing, which is just a way of finding more research. And that was broken down into smaller steps. Get the references from a paper, review the summary, and then save what you find into a database. Super simple, right? And this is where the magic happens. The developer starts handing out the jobs. Reviewing the abstract? That's a perfect job for an AI that's great with language. So it goes to the text review agent. Getting references means using an outside tool, so that goes to a tool driver agent, which then uses a specific piece of code to do its thing. See how the feature block model is like this living document that tracks the whole collaboration as it happens? Okay, but how do you keep this whole human AI team from going off the rails?
Well, CoPMA gives you a set of what it calls co-programming patterns. These are basically just a collection of proven strategies, a playbook, really, for dealing with the typical problems you're going to run into. And these patterns basically come in three flavors. First, you've got initialization, which is all about getting started. The developer could just say to an AI, hey, draft a plan for how to review a paper. Then there's refinement, which is about using the AI's own feedback to make things better, like asking it to rewrite some code to be more efficient. And finally, and this is a big one, refactoring. This is where you decide to turn a task that the AI does into permanent, reliable code, maybe because it'll be faster or more predictable that way. So that brings us to the last and honestly the most exciting part. All this sounds great in theory, but did it actually work? What were the real results? Let's take a look at the numbers. Whoa, I mean, just look at these numbers. The results from this case study are kind of mind-blowing. When you compare it to a normal development project, Comba cut the building time by more than half, had the AI write hundreds of lines of code by itself, and was almost perfectly accurate. Let's dig into each of those. First up, speed. A single developer just working on this as a side project built a fully working app in only 18 hours. Just to give you some context, the estimate to build this the old way was over 40 hours. So what was supposed to take a full week of work got done in like 2.5 days? That's a huge difference. And get this, the AI wasn't just a helper, it was a real partner in crime. It wrote around 350 lines of Python code, which was more than half of the final application. This completely changes what a developer does. Your job shifts from writing every single line to guiding, editing, and putting together the AI's creative work. And finally, the big question. Was it any good? Oh yeah, all that speed didn't mean sloppy work. When a human medical researcher double-checked what the AI did, its analysis of the research papers was 99% accurate. That is just an incredibly high-quality, reliable result from an automated system. So what does this all boil down to? This quote from the research paper says it all. This whole co-programming thing isn't just about coding faster. It's about getting rid of whole categories of boring, tedious work, like writing complicated database queries by hand, and just letting the AI agents take care of it for you. And that really leaves us with this huge, exciting question. We've seen that building software this way is faster, it works better, and the quality is top-notch. It changes software development from just giving a machine instructions into a creative conversation between a person and a whole team of AIs. So when this becomes the normal way we build things, what kind of amazing stuff, things we can't even imagine right now, are we going to create? That's the future this opens up.